Okay, so a 25,000 seat amphitheater will sell tickets at $55 and $85 for a U2 concert. Let X and Y be the amount, the number of tickets that will sell for $55 and $85 respectively. Assume the show will sell out. That's an important component to this whole thing. Part A, let R equal to f of x be the total revenue in dollars from selling the $55 and $85 tickets. Find an equation of f. Okay, so we first have to think about what revenue means. So revenue is the total amount of money collected, right? All of the money collected. That's different from the profit. The profit is how much is left over, how much you get to keep after you pay off all your debts, all your expenses. But here we're just focused on the revenue, how much money you're going to collect. So in general, we'll say that the revenue, the total amount of money collected, is going to be equal to the amount of money from the $55 tickets plus the amount of money from the $85 tickets. Right? So you combine those two things together and that'll let you know how much money you collected all together. So the amount of money from the $55 tickets can be represented by 55x, right? Where x has been defined to us as being the number of tickets that will sell for $55. So once we figure out how many tickets are sold for $55, we can multiply 55 times x, and that'll give us the amount of money you collect from selling the $55 tickets. And so in the other one, we're saying that y is the number of tickets you sell for $85. So this would be 85y. Right? So together they give you the total revenue. Good? Questions? No? Okay, so we have an equation for revenue. Revenue is equal to 55x plus 85y, but there's too many unknowns here. Right? I don't know what this is. This is an unknown value. I don't know what this is. I don't know what that is. 3 unknowns. It's too many unknowns for us. We'd like to reduce this down to just 2 unknowns instead of 3. And to do that, we're going to have to find some other statement that's true about these things. So the x and y, we know something else that must be true about those two.
25,000 seats.
They have to add up to 25,000 seats, right? And that's because they told us it was a sellout crowd. Y represents the number of tickets you sell for $55. Y represents the number of tickets you sell for $85. So together they got to add up to the total number of people at the concert, which is 25,000, right? 25,000 seats. Okay, so now we have 2 equations, this one and this one. So what we could do is replace one of these variables with this equation. And in particular, they told us to find f of x. There's nothing special about it. They just told us to find f of x. So I want this guy up here to have nothing but x's in it. So I'm going to replace the y there with this equation. So I'll get 25,000 minus x equals to y. And that is what I'm going to plug right into there. Okay. So then I'll get that the revenue is equal to 55x plus 85. And then instead of that y, I'm going to write 25,000 minus x. Where this is the y. Y equals 25,000 minus x. Good. Need some room anyway. So let me scoot that over there. So we have that the revenue is equal to 55x plus 85 times 25,000 minus x. Okay, so I'm going to distribute, combine some like terms. What do we get? We get 25, 1, 2, 3 times 85.
2,125,000.
Good, so this will be 55x plus 2,125,000 minus 85x, which will be negative 30x plus 2,125,000. And this is revenue, but now we finally managed to rewrite it as a function of just x's, which is what they asked us for, so I can rewrite it as f of x, where f of x is the revenue of concert. Good? Questions, comments, issues?
So that's the answer.
So far, well, for part A, yeah, it says let R equal to f of x be the total revenue in dollars from selling the $55 and $85 tickets, so find the function f. So this is the answer to part A. Right, let's explore it. What kind of an equation does this look like? What does it fit? The form of a... Fits the form of a linear equation, right? Where this is the y equals mx plus b, right? So it turns out to be a linear equation. Okay, let's find some values for this. Let's evaluate this for a few results and interpret it. So let's create a table. I'll put it over here. Let's create a table where I have x and I have f of x. So what happens when I put in a 0 there? If I put a 0 there, I get 2,125,000. Okay, so write a little sentence to describe what that means.
So the
Zero
zero.
what? What kind of a thing is the 0?
The $55 tickets. So
Okay.
$55. If $55 tickets were sold, that meant that 2,125,000 white tickets were sold.
Close, really close.
Oh, the profit was, the revenue was.
The revenue was 2 million. Okay, so how can it be that if you sell 0 tickets at $55, your revenue was 2,125,000?
They sold 25,000 tickets at the
The rest, correct, exactly. The rest, which is built into this equation, is the Y's, the $85 tickets, right? So if we sold 0 tickets for $55, that must mean that we sold 25,000 tickets at the $85 price, which is why we collected $2,125,000, right? Automatically, the rest of them are the other kind. So if we put a 1 here, then the answer here is going to be $2,124,970. How did I know that so quickly?
You subtract 30. 'cause
I
it's one.
subtract 30, good. The slope here is 30, so when I put a 1 there, I'm going to subtract minus 30 from this amount. So this means that I sold 24,999 tickets at the $85 price range, 1 ticket at the $55 price range, and so together we collected $2,124,970, right? It's pretty easy to come up with some of these other ones. How about a 2 there? That means this will be 2,124,940, right? An additional $30. And that means that this will be 24,998 tickets were sold for $85. 2 tickets were sold for $55. And together we make, we collect a total of $2,124,940. So for every change in x here, every time this goes up by 1, this goes up by 1, then this goes down by 30. This goes down by 30, which is one way to describe slope. For every additional for each additional ticket that you sell for $55, we lose $30 from the total revenue, right? Because you can think of it as an opportunity lost. We could have sold that ticket for $85, but we only sold it for $55. So we lost the opportunity of making that extra $30, right? And based on the way we set up our equation, when we have 0 here, this represents the most amount of money you can collect, right? That's when you sell all of them for the expensive amount. So we take the most you can possibly make, $2,125,000, And then for every ticket that we take away from, from the $85 pile and put it over in the $55 pile, we're losing $30 from that total every time. Does that make sense?
Yeah.
Good? I mean, you can kind of think of it like maybe everybody, 25,000 people, maybe there was like a promotion where if you buy the regular price of $85, but then you get to the stadium and if you're wearing a t-shirt from the band or something, they'll give you $30. Like that's the promotion that they offered. So maybe they collected all 2,125,000 because they sold all 25,000 tickets for $85. But then the day of the concert, you're like, okay, I guess we gave that guy $30 back. You know, you take it away from the full amount of money you collected and you give him his $30. So now it goes down to 2,124,970. Oh, another person has a t-shirt, damn it, okay, give him $30. So you keep reducing it, right? So for every additional person that you have to give them the money back to, for every additional person that only paid $55 instead of $85, then the total revenue collected decreases by 30, right? That's one way to look at it. Good? Questions? Okay, so for part B it says use a graphing calculator and use a graphing calculator table to find the values of 0, 5,000, 10,000, ... right? So go on, continue in that pattern, 5,000, 10,000, 15,000, 20,000, 25,000, and find various values. So we could just, do it by hand. It's really not that difficult to, fill in the blanks here and figure out what happens. Figure out what happens when this is 5,000. Figure out what happens when this is 10,000. So it's really not that hard. But it's still nice to be able to learn this shortcut in a calculator that we're about to do because they could get pretty crazy. It could be a lot of work to do it all by hand. So it's a nice shortcut to know. Okay, so we're going to get our calculators out. We're going to use this function right in here. And we're going to recreate this sort of a table on our calculators where we input the X values, how many tickets sold for 55, and the output is going to be that guy over there, the total revenue collected. All right, so we turn on our calculator, and wherever you're at, wherever you find yourself, just get out of it. Quit. Clear. So I'm going to go over to y equals, and there's a bunch of equations there that, from a different problem, they don't affect me, so I'm just going to clear them, get out of there. Clear. Okay. Notice up here that plot 1, plot 2, and plot 3 are deactivated. They're not dark. If one of them is active, then it'll look like this. See, now plot 2 is active. It's going to try and do some plotting of the scattergrams, the little dots, and that might cause an error. I don't want that. I don't want to graph that right now. So make sure you deactivate them all. So if one of them or if any of these are dark like this, then you got to go up with your arrows, highlight them, hit enter, and then pull away from it, and you'll see that it's no longer active. Okay, so make sure they're all deactivated before you do this. All right, so now we're going to type in an equation. It doesn't matter where you put it, but just keep track of which y you used. So just to move away from it, I'm just going to use y sub 3. So y sub 3 is going to be equal to negative 30 x plus 2,125,000 there it is. Okay, so now once you type it in there, you're going to have to do this only one time. You got to set up your calculator. You got to go to table set, which is right above window. So you hit second table set. That'll take you to this window. Okay. Now what we need is for the independent variable to be under ask and for the dependent variable to be under auto. It's got to be in that order. If it's not in that order, use your arrows to go down there and then hit enter to select what you need. Okay. The table start and the delta table, that part doesn't affect us, so leave it alone. So the independent has to be under ask and the dependent has to be under auto. Okay? All right, so once it's like that, you shouldn't have to change this anymore unless you take your batteries out of your calculator or something, or reset it to the manufacturer's default status. But other than that, it should remember it, so you shouldn't have to do this all the time. And now we're going to go to table. So second table, right above graph, and you should get something that looks like this. Whatever you get, just delete, 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 delete. Get rid of all of it. Okay. All right, so what this is a place where the calculator will automatically evaluate the function that you've selected to write into y sub 3, and you get to type in the value of the independent variable. So for instance, to recreate the table we just did on the board, if we type in a 0 here, we end up with that number, and I know it's a big number, so it's hard to express it just in that little line right there. So if you want to see exactly what it is, you got to use your arrows to get up to it, and there it is. So it's 2,125,000. Yeah, that's what happens. When we sold 0 tickets for $55, the rest of them were sold for $85, and I know that the revenue was 2,125,000. Okay, let's try the other one. So then we found out that if we typed in 1 into here, use your arrows to go over there and see it. Yeah, that's what it was. If we sold 1 ticket for $55, therefore selling 24,999 tickets for $85, then we collected 2,124,970. Okay, so this is a really good way to evaluate our function for various results. You can just fill them all in there, and we can go over here and figure out which one's which, right? We can also, just to kind of, for sake of completeness here, I can go over to y equals, and then I'm going to type in a little equation for the number of $85 tickets. So I know that together there's 25,000. So if I do 25,000, 1, 2, 3, minus x, that should tell me how many of the $85 tickets I'm going to sell. Okay, so let's go back to the table. And it automatically puts them on there. So see, y sub 2 is how many $85 tickets. X is how many $55 tickets. So when there's 0 $55 tickets, there's 25,000 $85 tickets. Together, they give me a revenue of 2,125,000. Let's go down here to this one. This is saying that when I sell 3 tickets for $55, and I sell 24,997 tickets for $85, that the total revenue collected is $2,124,910. Good? Questions? So in particular, for part B of this question, they had asked us to figure out what happens when this is 5,000, 10,000, 15,000. So let's type them all in here. 5,000, 10,000, 15,000, 20,000, 25,000. Okay, so let's go through these. This is the case when we sell 5,000 $55 tickets. Therefore, we sold 20,000 $85 tickets, and the total revenue was $1,975,000. Okay. Down here, this is the case where we sold 20,000 tickets for $55, only 5,000 tickets for $85, and our total revenue was $1,525,000. And finally, this case down here, this is the case where we sell all $25,000 tickets, 25,000 tickets for $55 each, 0 tickets for $85, and we got a total revenue of $1,375,000. Okay, so that was a useful calculator feature to be able to fill out the table, a table based on F. You punch in F and it tells you how many tickets, when you select how many tickets of the $55 you sold, it automatically calculated how many tickets of the $85 you sold and then gave you the revenue as a function of X. But there's nothing special about X. What if you were asked to find F of Y? How would that change things? So let's go back to this guy. The total revenue collected from either tickets is equal to the amount of money collected from the $55 tickets, which is X is how many. The amount of money plus the amount of money collected from the $85 tickets, of which Y is how many of those you sold, And we know that x plus y is 25,000. They asked us to find f of x. We want an equation that only add x's in it. But what if we're asked to find f of y? How would that change things here? And what is the final equation? So find f of y is our new mission. Okay, so this was the original equation we had. Revenue equals to $55, $55 times x, the number of $55 tickets, plus $85 times y, the number of $85 tickets sold. And we also had the other separate equation of x plus y must be equal to 25,000, since we were told it was a sold out concert. In the previous one we solved for y there and plugged it into here, so we had nothing but x's in it. But what if we do the opposite this time? X equals to 25,000 minus y, and now we replace this x right in here. So $55 times 25,000 minus y plus 85y. Okay, so distribute and combine line terms. So we're going to get 1,375,000 and we're going to get minus 55y plus 85y, and all of that is equal to the revenue. Okay, and then we combine these things together and we end up with 30y plus 1,375,000 this way. This is the revenue. But now it's only in terms of y, so I can write it as a function. Let's write it as a function g of y. Okay, so we got two functions. This is g of y equals to this, and in the previous one we had f of x. How do they compare? What's the difference between the two of them? So someone noted that the slopes are very similar. The other equation had negative 30, this one has positive 30. And when we plug in 0 into here, the ordered pair 0, comma, right, if we create a table here with y's and g of y's, then when y is 0, we would end up with 1375000. So when we sell 0 tickets at $85, therefore selling the rest of them at 25,000, all 25,000 tickets for $55, we end up making a revenue of 1,375,000. Good. So they're related to each other. Let's put them side by side. So f of x was negative 30x plus 2,125,000, and g of x, g of y was equal to positive 30y plus 1,375,000. Okay, so when we created a table of x's and y's and revenue, okay, so if we put a 0 in here and we want to find the revenue, then we go to this one. It's a function of x. And if I put a 0 into there, I would get 2, 1, 2, 5, 0, 0, 0. Right? So as a function of x, I would get that. So this is f of 0. On the other hand, if I sold 0 tickets for $55, then that means I sold how many for $85?
25,000.
25,000. So now if I go to my g function and plug in 25,000, I'm going to get the same answer. So this is equal to g of 25,000. Good. So if I go to the g function, g of y, it'll give me the same answer. But I just got to plug in the appropriate amount. Got it? Let's try some other random one. How about if I want to know what happens if I put 1,300 and let's say 1,300 tickets there. Now, how much did I collect if 1,300 tickets were sold for $55? And how many are sold for 85 then? 23,700 tickets must have been sold for $85 then. So in order to figure out the revenue, I got two options, and they're both going to give me the same answer. From this perspective, then if I plug in 1,300 into this function, I'll get our answer. So f of 1,300 is going to be equal to negative 30 times 1,300 plus 2,125,000. And what do we get? Negative 30 times 1,300 plus 2,125,123, which is 2,086,000. And we'll get the exact same answer from g of y, where y in this case would be 23,700. Which would be equal to positive 30 times 23,700 plus 1,375,000. So 30 times 23,700 plus 1,375,123. Yep, exact same answer. 2,086,000. Any questions? No? So they're both related that way. You just have to be careful about how to evaluate, how to get the values of x and y for a particular situation that you're after. What about the graph, like if we graph them? Let's do like a rough sketch of these. So if we... If we took f of x equal to negative 30x plus 2,125,000, it's a linear equation, so I know that the graph is going to look like a line. The slope is negative 30, so for each additional value of x that we get, we reduce the total result by $30. So this is going to look something like this. So I'm going to input x, and the answer is the revenue. Right? I know we're used to saying y, but in this case I don't want to say y because the other function is a function of y. So I just want to say the total revenue, f of x. And so I know that when x is 0, I'll be somewhere over here. This would be something like 0, 2,125,000. And then as the number of x increases, this goes down to say something like there. And this represents the biggest value that x could be. What is the biggest value that x can be in this situation? 25,000, right? And at 25,000, when we sell 25,000 tickets for $55, we collect a total revenue of $1,375,000. Right? Notice that this does not go all the way down, right? Because we're assuming it's a sellout concert, and this is revenue. If it went all the way down to over here, if this was allowed to go all the way down there, then that would mean what down there? The revenue was
0, even though this is
0. Well, that doesn't work in this case because we're assuming it's a sellout concert, and the worst you could do is that you sold them all for the cheaper price of $55, which means you made $1,375,000. So this little segment here is just not valid for our situation. Good? Okay. This is the equation of this line right in here. The slope of this line is negative 30. So for each additional x value, right, for each change of 1, I'm exaggerating here, but for each change of 1 in that direction, what's happening to this direction? Actually, I should write it this way. For each additional 1 ticket sold for $55, the total revenue decreases by 30. Good? Questions? Yes? Okay, so what's the domain of this function? It's from 0 up to 25,000. And what's the range?
1,375,000.
Exactly, going in this direction. So this over here is the range, all possible answers in this situation. So that's the range. And this direction, if you squash it this way, where it touches along the horizontal axis, is the domain, from 0 to 25,000. And so the range is from 1375000 up to 2125000. Good? Yeah.
Wait, so is that still all possible answers, or there's a point where it stops, right? For the range?
The range is from here to here, right? There's all possible answers between 1,375,000 up to 2,125,000, right? Everything in this section. Good. Questions? Right? Because this is achieved when we sell 0 tickets for 55, which means we sold all 25,000 tickets for the more expensive price. Good. What about the other function? G of y. It was equal to positive $30, x, plus 1375000. So the slope is positive in this case. So I know that the line is going to look a little different. It's going to be a function of y. Keep that in mind. It's not up here like it normally is. And up here, this is just revenue. Revenue. Which is equal to g of y in this case. Okay, so when y is 0, then we had something like here at 0, 1375000, and then it went up to some amount where this is 25,000, 2,125,000. So very similar. Right? As y increased, the number of tickets you sold for $85 increased. The more you sold for $85, the bigger the revenue got, because you were selling tickets for 85 instead of the 55. And so what is the domain? Well, the domain is the same. Domain is going to be equal to 0 up to 25,000. And the range is exactly the same as this one as well. From here to there, which is 2125000. Range is from 1,375,000 to 2,125,000. Any questions? Okay, so for part D, how many of each ticket must be sold for the revenue to be equal to 1,510,000? So really we came up with two different equations. We could really answer part D in any way we want. Either way you look at it, we want to figure out what is the input value so that the total revenue is 1,510,000. So let's say that in this picture over here it's like right there. Let's say this value represents 1,510,000. So I want to know this. I go backwards and I go this way. I want to know this. What is this right here? What is the value of this input value of X in this case? What is the value of X? How many $55 tickets must I sell for my total revenue to be equal to 1,510,000? Which is really the exact same question over here. If 1,510,000 is somewhere in there, I want to go this way, and then I want to go this way, and figure out what this is. What is the value of y in this function that gives you a result of 1,510,000? Good? So you can solve it in either way. And in this case, if you solve that, you'd get the answer for x. But then, obviously, y is connected because they have to add up to 25,000. And over here, if we solved it here, we would get a value for y. Oops, nobody told me this is a y in here. We'd get a value for y, and then obviously we can get x because they're connected. They have to add up to 25,000. Good. Any questions? Any questions? Any questions? Okay, so let's set it up. So if we want to use f of x, then I want to figure out the value of x that results in that. So 1, 5, 0, 0, 0, 0. I want to find x such that that's true. So I'm going to set it up as negative 30x plus 2,125,000 is equal to 1,510,000. Right? My function f of x has to be equal to that. Find the x value that gives you that result. So subtract this, divide that, we get negative 30x is equal to 1,510,000 minus 2,125,000. And so x will be, negative 30x will be equal to 1, 5, 1, 0, 1, 2, 3, minus 2, 1, 2, 5, 1, 2, 3. Negative 615,000 divided by negative 30. $20,500. So if x is equal to 25,500, automatically y would be equal to
4,500.
Right? When x is equal to 20,500, I know there's 25,000 seats that are going to be sold out concert, then the rest has to be 4,500. So we can double check. If we plug in this number into our function for x, we should get $1,510,000. And when we plug in this value into our g of y function, we should get the exact same amount of 1,510,000. Any questions?